Right, this video is for the questions 3, 4, and 5 on your Unit 2 test exam review. All right, I reordered some of the questions, so the video is a little bit different, but this video is only for 3 through 5. Let's see, so in these questions, you have to determine whether the relation shown is a function, if it's one-to-one function, and if it's even, odd, or neither. Now, to determine if something's a function, we'll look at A. Remember, you have to pass the vertical line test. And this graph would pass the vertical line test because if I drew a vertical line, it only crosses the graph one time. So that first parabola is a function. Now, one-to-one means that you pass the vertical line test, you are a function, and you pass the horizontal line test, which means you would cross the horizontal line just one time. And that graph fails the horizontal line test, so it's not one-to-one. Even, odd, or neither. These are kind of hard to remember. Even means that you're symmetric over the y-axis. Odd means your graph is symmetric over the origin. And neither means you're symmetric over neither of those places. So this graph looks like it's symmetric over the y-axis right here. So it is an even function. Number 2 is not a function because it's going to fail the vertical line test. If you're not a function, you cannot be one-to-one, because you have to be a function to be a one-to-one function. And it is not symmetric at all over the y-axis or the origin. So it's a no, neither. The third graph down here is actually a function. It's hard to tell, but remember, my favorite word is an asymptote. And there's an asymptote here at the y-axis where neither sides of that graph actually touch across the y-axis. So that part of the graph is not failing the vertical line test. So it is a function. Now, for the same reason, it's also a one-to-one function because there is a horizontal asymptote here at the x-axis. So you're not actually touching that horizontal line. So yes, this function is also one-to-one. And this graph is actually odd. It is symmetric over the origin. And here's the origin. You can tell because opposite quadrants are exactly the same. Right? So if the opposite quadrants across the origin are reflective across each other, then that would mean that it's reflecting over the origin. Last graph. This linear function is a function. It passes the vertical line test, and it passes the horizontal line test. Right? It also is one-to-one. Now, because it has a y-intercept down here at -4, that is not reflective over the y-axis or the origin, so that particular line is neither even nor odd. All right, number 4, you have to remember all your parent functions. Now, these next 8 graphs, 4 here and then 4 that you have to make, are just a sampling of the parent functions we did in class. So you still need to know all of those parent functions. This first one is called the absolute value of x. The second one here is your parent function for a line, which is just f of x equals x. See here, we are at the origin, the point 1, 1, the point 2, 8 up here. And if you think about pattern 1, 1, 2, 8, you are cubing that x value, which is x to the third. And this graph is the square root of x. And here we have the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. All right, you still need to know the rest. I think we did like 8 or so parent functions. That's only 4 of them. And then here we need to graph the parent functions. Okay, again, I'm only giving you a few, but you still need to know how to graph all of those parent functions. This is going to be on the no calculator part of your exam, so make sure you can graph the parent functions without a calculator. I chose y-squared for the review because we're using it a lot with parabolas. So you need to, especially when we come back from break, be able to graph this one. So if you start at 0, 0, 0, right? Put the x values in into the function here. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And hopefully you know that a parabola is symmetric over the y-axis. So you can just copy those points over. And there is your graph of the parent quadratic function. That graph is, it is a function, but it is not one-to-one, fails the horizontal line test, but it reflects over the y-axis, so that is an even function. X cubed, I kind of talked about this on number 4. X cubed, again, just like the first one, plug your x values into the function. If I start at 0, I have 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Alright, then I go the other way. Negative 1 cubed is negative 1. And negative 2 cubed is negative 8. That's all that's going to fit on the grid. And when we graph here, remember, it kind of flattens and twists a little through the origin and goes straight up. You need to be able to plot those points accurately. Yes, that function is one-to-one. It passes the horizontal line test. And that graph is actually symmetric over the origin. So it's odd. Opposite quadrants are reflecting. They're the same as each other. All right. Square root of x. Also one that we saw in the other graphs where you need to know how to make. Plug your values in. Now you know if I plug square root of 0 in, that's 0. Square root of 1 is 1. Square root of 2 is irrational. Square root of 3 is irrational. Square root of 4 is 2. And the next non-irrational x or value I can get from an x is at 9. 3. Now if I put any negatives in there, square root of negative 1, you know that's I, and my 8th grade's not going to like this, but that's not on the real number line, so we can't plot those points. So this is the only part of the graph we can make. Yes, that function is one-to-one. It passes the horizontal line test, but it is not symmetric over the y-axis or the origin, so that would be neither even nor odd. Finally, y equals 10 to the x. All right, this is an exponential function. We did our exponentials units. I'm going to have you graph it this time on the review. I'm going to put 0 in to start. 10 to the 0. I'll make a little table this time. 10 to the 0 is 1. So at x equals 0, I have to plot 1. And at 10 to the first, I have 10. So there's 2 points over there. I can't fit 10 to the second, which is 100 on there. If I go the other way, 10 to the negative 1, well, remember, a negative exponent flips that 10 to the denominator is 1 over 10. So I would have a point somewhere down here. 10 to the negative 2 would be 1 over 10 squared, which is 100. And those numbers just keep getting really, really close as we go. Remember, it's exponential, and there's an asymptote at the x-axis. So you can just draw that asymptote in, and that would be the graph of 10 to the x. That graph is one-to-one. It passes the horizontal line test, but it's neither even nor odd. It's not symmetric over the y-axis or the origin.